Hello everyone, welcome to IIT and Gate classes. This is lecture 18 on POC, and in this lecture we are going to start construction of Turing machine for A power n, B power n. Okay, so I am starting this lecture from the point where I have left the previous lecture. Okay, so please watch my previous lecture to get proper idea about what exactly is Turing machine and so on. Okay, so I am directly starting the construction of Turing machine for A power n, B power n. And in the previous lecture itself, I have given you a small logic about how we can design this Turing machine. Okay, so let me design it properly. Okay, so let me take one more string. Okay, for complete clarity. Okay, so let me take the string as, say, same string. Okay, let me take the same string, triple A triple B, and we have blanks. Now Turing machine will be its read write head will be positioned on the first symbol of input, that is A, and state will be initial state, that is Q naught. So as soon as on Q naught, as soon as Turing machine read A, what it will make, I have already told you in the previous class that it will make X and move forward. Okay, so let me design the move. So initial state will be Q naught. Okay, on Q naught, as soon as A is read, it will make it as X and move forward in the search of B. Okay, so I will say on Q naught, as soon as A is read, then it will make it as X and move to the right. Okay, so move to the right. Okay, and the state will be Q1. Now Q1 will be in search of B. So obviously Q1 will ignore all the A's. So what exactly should be the move on Q naught? As soon as A is read, A will remain as A and it will keep on moving right. But as soon as it finds a B, as soon as Q1 finds the B, it will make it as Y and move left. So as soon as Q1 finds the B, it will make it as Y and move left. Okay, so on the left, okay, so it will move left. So that means Turing machine read write head will be here now. So what exactly now should be done? Now we should be in the search of X. Okay, as soon as X is found, we should move to the right. So this will be done by a new state. Let us say that state is Q2. So Q2 will leave all the A's now. Okay, see here carefully. Q2 will see on Q naught, A was read, it was made X and move forward. So here, okay, let me design it properly. On Q1, Q1 read this A, it will ignore this A, move to the right. Now again, Q1 will read this A, it will ignore that A, move to the right. Now Q1 has read this B. So I have made this as Y and move towards the left. So see here, why I am changing the state here? Because mindset is changed. Q0 mindset is to make A as X and move to the right. Q1 mindset is ignore the A's, and as soon as it finds the first B, it will make it as Y and move towards the left. Okay, now the state will be Q2. So Q2, see here carefully. Now what exactly will be done? Now Q2 will be here. Okay, so Q1 has read this B. Okay, let me do it again. Q1 has read this B, make it as Y and move towards the left. Now state will be Q2. Now Q2 will ignore all the A's and move towards the left only. So Q2, it will read the A, it will leave the A as it is. It will read the A, then it will leave that A as it is and move towards the left. Okay, so Q2 will do like this. Now what will happen? See here carefully. So Q2 will keep on ignoring the A's, but as soon as Q2 find the X, as soon as Q2 find this X, it will remain remain as X only. X will remain as X only and move towards the right. Okay, move towards the right, and on right, what should be the state? Now you have to change this A as X now. So changing A as X is done by Q naught. So we will jump to Q naught. Okay, so let me now show you properly what exactly we are doing now. Okay, so on Q2 has read X. So we will jump to Q0 and we will say what Q2 has read X. Sorry for that. Yeah, Q2 has read X. It X will remain as X only and move towards the right. Now we are at Q0. So Q0 will read this A, make it as X, move towards the right. Okay, see here carefully, move towards the right. Now what will happen? Okay, so now state will be Q1. Q1 will ignore the A, it will move towards right. Q2 needs B, sorry, Q1 needs B na. So Q1 will read this Y also. Okay, so Q1 is in the search of B. So Q1 will read this Y. We have not given the move, so we have to give the move also, and the move will be like this. Okay, so move will be, it will ignore all the Y na. So Y will remain Y and it will move towards the right only. Okay, yeah. Now see here carefully. Now Q1 has find the B. Okay, Q2, see here carefully. Q2, see, let me do it again. Q0 on reading this A, it will make it as X and move towards the right. Now we will be at Q1, or Turing machine will be at Q1. Q1 will ignore the A's, that means it will remain as A only, move towards the right. Now Q1 has read the Y, but we have not given the move that Q1 can read Y, so I have given the move Y. That means Y will remain Y and move right, because it is in the search of B only. Q1 is in the search of B only. So now it has find the B. So it will make this B as Y and move towards the left. Okay. So now the state will be what? See here, state will be Q2. Now Q2, see here carefully. Okay, see here carefully. So Q1 has read this B now. See, Q1 has read this B, make it as Y and move towards the left. We will add Q2. So Q2 has read the Y. I have not given the move that Q2 can read Y. So we have to give the move, because now Q2 is in search of X now. As soon as Q2 find X, Q2 will remain it will remain as X only and move towards the right. Now Q2 is in the search of X. So while searching X, it may find Y also and it may find A also. So A will remain as A, move towards the left. So Y, similarly for Y also we have to write Y will remain Y and it will move towards the left. Now finally Q2 has read the X, X will remain as X and move towards the right. Now Q0. Okay, so we have jumped to the state Q0. Q0 will read the A. Okay, A will be made as X. Okay, and it will move towards the right. Okay, so it will move towards the right. Now in the on the right, it has find the Y. So Y will remain Y and it will move towards the right only. So on state Q1 we will keep on moving the right. Okay, then we find the B. Okay, then we find the B. Now what will be done? B will be made as Y and move towards the left. B will be made Y and move towards the left. On, so we will be at Q2 only. Now Q2 will do what? Q2 will read all these two Y's. Okay, and these two Y will remain Y only and move towards the left. Now it has find the X. X will remain X and move towards the right. So now see here carefully. Q0 has read the Y. Actually Q0 read the A na, but Q0 has read Y now. If Q0 has read Y, that means what? All the A's are now converted to X. Hence, now our main idea will be that since all A's are over, so here we should find only Y. We should not find any B. So now what should be the move? As soon as, see here carefully, as soon as Q0 read the Y, as soon as Q0 read the Y, Y will remain Y and it will move towards the right, and say state is Q3. Now Q3 will have only one thing, that means it will read Y, Y will remain Y and it will keep on moving the right. As soon as, okay, as soon as Q3 finds the blank, as soon as Q3 finds the blank, okay, so it will go to final state, okay, and string will be accepted. So Q3, as soon as Q3 read the blank, blank will remain as blank. We can move either left or right, whatever direction you want, and move to the final state, that is Q4. Okay, Now this is your Turing machine. Now it's homework for you that you have to check it out for, or you have to run this Turing machine for say 4 A's and 4 B's, and here we have blanks. Okay, this is homework for you. Try to run this Turing machine for this string. Okay, now I will show you some example. Okay, so let me show you a string like triple A double B. Okay, triple A double B. What will happen? Just try to figure it out. Please pause the video and try yourself. And now I will explain. Okay, please pause the video and try yourself. Okay. So I hope you have paused the video and try it yourself. Now I am going to explain you. See here carefully on Q naught. See now I won't refer this. I will just try to visualize. I will just try to visualize everything. Okay. So please try to visualize with me also. So A will be cut. A will be cut as X. Okay, and we will move forward and cut this Y. Cut this B as Y. Now cut this A to X. Cut this B as Y. Now cut this A as X. Okay, so A is made X, and Turing machine move to the right now from Q naught. Okay, so directly what I am saying is we will be at Q naught. Q naught will read this A, make it as X, and move to the right, and it will keep on moving right. Okay, now state will be Q1 now. So Q1 will ignore all the Y's. See here carefully. Q1 will ignore all the Y's. Q1 will ignore all the Y's, but Q1 will read the blank because Q1 is in the search of B, but Q1 will not be able to find the B, and Q1 will read the blank. So Q1 reading blank means what? We have not specified the move in this Turing machine. That means Turing machine will halt in a dead configuration. Please note it down carefully. Hence string will be rejected. Why string will be rejected? Because Turing machine halt in dead configuration. Turing machine halt in dead configuration. Why halt in dead configuration? Because we have not specified the move for Q1 reading blank. So indirectly I want to say Q1 reading blank. This move is not specified. Let me give one more example. So number of A's, see in this string number of A's and number of B's are equal. Here also, which I have given you homework. See here carefully, number of A's and number of B's are equal. Okay, we have 4 A's and 4 B's. 4 A's and 4 B's. See here carefully. Now I will and I have given you one string in which number of A's, okay, number of A's are more than number of B's. Triple A double B. Next example should be number of A's are less than number of B's. Okay, so now let's take that example. See, double A, triple B. Please pause the video and try to answer yourself. What will be the answer? Please pause the video and try yourself. Okay. So I hope you all have tried by now, and let me show you now what exactly we are going to do. Okay. So firstly, see here. I am doing in a bit faster way. I will cut this A as X, cut this B as Y, cut this A as X, cut this B as Y. Now I will come back, okay, in the search of X. So who is in the C? We have cut this B as Y now. So now we will come back in the search of X. Who is in the search of X? Q2. So Q2 will find this X. Okay, it will move to the right and state will be Q naught. Now Q naught has read the Y. Q naught has read the Y means what? Directly, indirectly, all the A's are now converted to X. That means number of A's are over now. Okay, or direct or indirectly we can say that Turing machine has read all the A's by now. Okay, so that means all the A's are now converted to X. Roughly we can say that all the A's are now converted to X. Okay, now Q1 will read the Y. So Q1 will Q naught will read the Y. Q naught will read the Y. So that means all the A's are now converted to X. Now it will remain, Y will remain as Y only, move towards the right, and state will be Q3. So on Q3, okay, on Q3, Q3 will read this Y also, and it will remain as Y only, move towards the right, state will be Q3 only. So Q3 has read this B. Please see here carefully. Q3 has read this B, but Q3 is not allowed to read this B. hence Turing machine will halt in dead configuration, so string will be rejected. So here again same to same, copy paste. So Turing machine halt in dead configuration. Turing machine halt in dead configuration. Or and what is the dead configuration? That configuration will be on Q3. B is read, which is not allowed. Okay, Q3 can read only Y, but here Q3 is going to read the B, which is not allowed. So Turing machine halt in that configuration. I hope I have made the point clear to all of you. Okay. So now let's jump to the next slide. Okay. Next question is A power n, B power n, C power n is greater than or equal to 1. The idea is exactly similar as we have studied in this previous question. Okay, idea will be exactly similar. So what should be the idea? Let me take one string. You will get your answer. See, suppose we have triple A, triple B, triple C, and here we have blanks. What should be done? A will be changed to X. This B will be changed to Y. This C will be changed to Z. Now we will move backward. Again, this A will be changed to X. This B will be changed to Y. This C will be changed to Z. Again, we will move backward now. This A will be changed to X. This B will be changed to Y. This C will be changed to Z. Okay, and finally, okay, we will say that everything is X, Y, and Z. That means no A, no B, or no C is left. That means what a number of A's and number of B's and number of C's are equal. So idea is exactly similar. Let me show you the idea now. Okay, let me make the Turing machine now. Okay, so first thing will be what? The state will be Q naught. Okay, initially Turing machine will be at state Q naught. Yeah, so on Q naught, as soon as A is read, A will be converted to X and Turing machine will move to the right. A will be converted to X, Turing machine will move to the right, state will be Q1. Now Q1 will ignore all the A's, okay, because it is in the search of B only. So it will ignore all the A's. So A will remain A and it will move toward the right. As soon as Q1 find the as soon as Q1 find the B will be changed to Y and it will move right. In the previous example, see here carefully, on Q1, as soon as it find B, it will make it Y, move left. Why? Because now we are in the search of X now. We will move backward now. Okay, so but here we won't move backward because now we have to make this C as Z also. So now B is converted to Y and it will move toward the right. Okay, and the state will be say Q2. Q2 will ignore all the B's. So B will remain as B and move toward the right. Okay, so all these B's will be ignored. Now C will come. So C will be converted to, or C will be changed to Z. Okay, so what should be the move here? So Q2 will ignore all the B's and Q2 will be in the search of C. As soon as Q2 find the C, it will make it as Z and move towards the left. Okay, because now same thing will be repeated again and again. So C is now converted to Z, or C is deleted and you can say Z is stored on the tape. So, or you can say read at head has written Z on the tape. Okay, so C is now deleted, Z is on the tape and it will move towards the left. Okay, so to repeat the same procedure again and again. So C will be changed to Z and it will move towards the left. Okay, so yeah, so now state will be say Q3. Q3 will what Q3 will do? Q3 will see here carefully. Q3 will ignore the B's, ignore the Y, ignore the A. It will be in the search of X only. So Q3, what Q3 will do? B will remain as B and it will move towards left. Okay, and Y will remain as Y and it will move towards left. A will remain as A and it will move towards left. So as soon as it find the X, same procedure will be repeated again. X will remain as X and it will move towards the right. So it will move towards the right. So again, we will be at Q0. Q0 will read this A. It will make it as X. Okay, then it will, so we will be at, Turing machine will be at Q1. Q1 will ignore this A. Okay, so Q1 will ignore this A and And see here carefully, Q1 will ignore this Y also because it is in the search of B. So I have to give the move. Y will remain Y and it will keep on moving right. Okay. Yeah. Now see, I really do not remember what are the moves, or indirectly I want to say I have not by heart these moves. Okay. I am just giving this taking the string and try to make the move. So this is the best way to design Turing machine, and you have to follow this way also, this way only. Otherwise, if you by heart, then you will obviously forget moves. So better is take one example and try to make the Turing machine according to that example only. Okay. So Q1 will read the Y will remain as Y. It will move towards the right. So Q1 will read the B will become Y, and it will move towards the right. Okay. Yeah. So Q2 will ignore the B. Q2 will ignore the B. It will keep on moving right. So as soon as Q2 find the C, it will make it as Z and it will move towards left. But Q2 Q2 can read this Z also, na? Okay, Q2 is ignoring the B's. Similarly, it has to ignore Z also because it is in the search of C. So I have to give the move. Z will remain as Z and it will move towards the right. Okay, yeah. So now C will become you can say read write head will replace this C by Z, and it will move towards the left. We will be at Q3. Q3 now see here carefully. Q3 now C will make Z. C will you can say read write head will write Z on the tape. Okay, and it will move towards the left, and state will be Q3. So see here carefully. Q3 will read the Z also, and I have not given the move, so I have to give move. That means Z will remain as Z, and it will move towards the left. Okay. Now see carefully. Now see carefully. Okay. So Q3 will ignore this B. Okay. See, Q3 will ignore this B. Q3 will I have given the move now, so it will ignore this B. Or directly B will remain as B, and it will move towards the left. Then it will ignore the Y's. Okay, it will ignore the A's. But as soon as it finds the X, it will X will remain as X and move towards the right. So now see here carefully. Q0 will read this A. Q0 will read this A. So this A will be converted to X, and it will move towards the right. So Q1 will ignore these Y's. It will keep on moving towards the right. Now Q1, as soon as Q1 find the B will become you can say as soon as B is read from the tape, read write head will write the Y, or it will replace the B by Y. Okay, and it will move towards right. Now Q2, see here carefully. Q2 will ignore all the B's. And here we have no B's, no problem. It will ignore all the Z's. We have two Z's, so these two Z's will be ignored. And as soon as Q2 find the C, it will become Z, or it will be replaced by Z. Okay, and move towards the left on Q3. Okay, so we will be at Q3. So Q3 will read this Z. Okay, so I hope I have made the point clear, but let me repeat properly. Okay, so Q2 will read this C and make it as Z. Q2 will read C, it will make it as Z and move towards the left. So Q2 has replaced this C by Z and move towards the left, and state will be Q3. So here we were here with Q2 now. So Q2 has made this C as Z and move towards the left. So state will be Q3. Okay, move towards the left, and as soon as reader head will move one symbol to the left, the state will be Q3. So now Q3 will ignore all the Z's. See here carefully. Okay, see here. Q3 will ignore all the Z's. Q3 will ignore all the Y's. Okay, A and B's are nowhere, so no problem. And Q3 will read this X. Okay, as soon as Q3 will read this X, X will remain as X and it will move towards the right. So now again, similar idea, Q0 will read the Y. As soon as Q0 read the Y, that means what? Your string number of A's have been completed. Okay, number of A's have been completed. So Q0 will read the Y. Y will remain Y. It will move towards the right. State will be say Q4. State will be Q4. So Q4 will ignore all the y. Y will remain y. It will move towards right. Z will remain z. It will move towards the right. It will keep on moving. Okay, it will keep on moving. Now Q4 will read the blank. Okay, as soon as Q4 read the blank, blank will remain blank. It can move either left or right. State will be Q5, which will be our final state. So I hope I have made the point clear to all of you. So this is your Turing machine for A power n, B power n, C power n, such that n is greater than or equal to 1. Okay, I hope everything is crystal clear to all of you, because I have taken example, and while tracing that example, I have designed the Turing machine. Okay, so now it's homework for you, because I have given you a crystal clear explanation for the previous question. So now it's homework for you. Try to trace example for double A, triple B, triple C, then triple A, double B, triple C, then triple A, triple B, double C. Okay, so here in the first example, number of A's are less, and in the second example, number of B's are less. In the third example, number of C are less. Okay, so please try to trace all these examples. This is your homework, and try to show in which state Turing machine will halt. This is your homework. Okay, now show on which see, obviously these three strings will be rejected by this Turing machine, because number of A's, B's and C's, all the three should be equal. But here the number of A's, B's and C are not equal, so obviously these three strings will be rejected. But how they will be rejected? So directly and indirectly, I want to say, obviously it will halt in that configuration. So what should be the configuration in which it will halt? Okay, or what should be exactly the that configuration? That means on which state you want to read some symbol which is not allowed, and so on. Okay, please try to explain yourself. You will get the idea. Okay, so roughly, I will give you hint for this. This is the first question, so I will give you hint. See, this A. Okay, so how you will check? I am showing you now. Please concentrate here. This A will be converted to X. This B will be converted to Y. Okay, this A will be converted to X. Let me show you properly. This A will be converted to X, or this A will be replaced by X, B by Y, C by Z. Come back, X, Y, Z. Come back in the search of X. Okay, and as soon as you find X, so who will find the X? Q3. Q3 will find X. X will remain as X, and it will move towards the right. Now Q0 will read the Y. Here careful. Q0 will read the Y. So it will move to the state Q4. Now Q4 will read the B. So for this string, that configuration will be Q4 is reading the B, which is not allowed. Okay. So here that configuration will be delta Q4B. Move is missing. So now I think you are comfortable. You will try to answer these two questions yourself. Okay. So that's it. So now I will show you Turing machine as transducer. Okay. So how Turing machine acts as a transducer, we are going to see now. Transducer means we are interested in output. Okay. We are interested in output. So let me show you now ones complement machine. So this is very simple machine. Okay. So Q0, initial state Q0. Let me take one string 1100. Here we have blank, 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 and blank. Initial state Q0. So Q0 will read this one. Okay, it will make it as 0 and move towards the right. So and state will be obviously Q0 only. Okay, we are simply finding one's complement. So we do not need to change the state, because state Q0 will handle everything. That means it will change 1 to 0, 0 to 1, and so on. Okay, so Q0 will read the 1 will be changed to 0 and move towards the right. So here Q0 will be here now. Q0 will read the 1, it will make it as 0 and move towards the right. Okay, so same move will be applied. Now Q0 will read the 0. So now 0 will become 1 now. So if Q0 reads 0, it will make it as 1 and it will move towards the right. So again Q0 will read the 0, it will make it as 1, move towards the right. As soon as Q0 read the blank, okay, it should halt. So as soon as Q0 read the blank, blank will remain as blank. Okay, and it can move either left or right, whatever direction you can give, and it will move to some halting state H. Okay, we are not making, we are not saying that it is a final state, because now we are interested in output. We are not interested in acceptance or rejection of string. Output means what? You want some output on the tape. So 1100, initially input was 1100 and output will be 0011. So on the tape itself we have got the output, that is 0011. Okay, so just like Millimore machine, in Millimore machine I have already told you that there is no concept of final state, because we were interested in output. We were not interested in given string is accepted or rejected. So here also we are not interested in given string is accepted or rejected. We are just interested in output only. Yeah, so I hope I have made the point clear. So this is one's complement machine. Okay, and H means halting state. Okay, next question, two's complement. Two's complement is again very easy. So let me give you one example. Say 11100. Okay, so here we have blanks. So what will be the two's complement of 11100? So I have already given you shortcut in Millimore machine also. Okay, but let me give you a small hint here also. Okay, so 11100 is the binary string, and you want to find two's complement. So you have to scan the string from right to left. All the zeros will be copy pasted. First one will also be copy pasted, and rest every one or zero we will do one's complement. So we will get this. Let me give you one more example. 10101110. Scan the string from right to left. Okay, copy paste all the zeros. Copy paste first one. Now you will do one's complement of these numbers. You will get 0, you will get 1, you will get 0, you will get 1, and here you will get 0. So this is the two's complement. This is a shortcut way. Okay, the simplest way is make one's complement and then add 1. Okay, so that will create problem for Turing machine. Obviously it can be done by Turing machine, but it's not that much easy. So better is you should do by this way. Okay, so this is the simplest way of finding two's complement. So scan the string from right to left, copy paste all the trailing zeros. First one will be copy pasted, and for rest of the bit we will find the ones complement. So now see here carefully. Initial state Q0, na? Initial state is Q0. So Turing machine will start from here itself, because by default read-write head will be placed where? On the first symbol of input string. Okay, so now what should be done? So Q0 will ignore all the zeros and ones, and it will move straight away for the search of first blank. As soon as it finds the first blank, it will move towards the left. Now we will start the two's complement procedure. So directly what I want to say is Q0, initial state Q0. It will ignore the zero, or directly I'm saying 0 will remain as 0, it will move towards the right. 1 will remain as 1, it will move towards the right. It will keep on moving right till it find the blank. So Q0 will find the blank. Blank will remain as blank, and it will move towards the left, and state will be changed to Q1. So directly now I want to say that Q1 Q1 will read this 0. Okay, because on Q0 should Q0 have read this blank. Blank will remain as blank, and it will move towards the left. So read-write head will be here. Okay, and the state will be Q1. Why we have changed the state? Because now our mindset is changed. Q0 mindset is ignore all the zeros and ones, and straight away it will find it will be the search of blank one. So it will ignore all the zeros and ones. Okay, and now Q1 mindset will be what? It will ignore all the trailing zeros. Directly 0 will remain as 0, and it will keep on moving left. So on on Q1, 0 will remain as 0, it will move towards the left. But as soon as Q1 find the 1, 1 will remain as 1, it will move towards the left. So here Q1 will ignore this 0. Here Q1. As soon as Q1 find the 1 will remain as 1 and it will move towards the left. So now state will be changed to Q2. Why state will be changed to Q2? Because now mindset is changed, because now we are going to do ones complement. Okay. Q1 is simply ignoring all the zeros. See, Q0 is ignoring each and every 0 and 1 because it is in the search of length. Q1 will ignore all the zeros. As soon as it will find the 1 will remain as 1 and it will move towards the left. So now state will be changed to Q2. Why state is changed? Because Q1 aim is to ignore all the zeros. Now Q2 aim will be to find the ones complement. Okay, or 1 will be replaced with 0, 0 will be replaced by 1. So here we will write as 0 will be replaced and 1 move towards the left, 1 will be replaced by 0 and move towards the left, and so on. Now as soon as Q2 find the blank, okay, blank will remain as blank and it will go to halt state. Blank will remain as blank. It can move either left or right, it's your own choice, and it will move to the halting state, that is H. Okay. Please note it down carefully. If you have any doubt, please try to visualize yourself and please try to run this Turing machine on this input 10101110. You will get the crystal clear idea. Okay. Now, and let me show you one more example. I think you may get confused here. So let me show you one more example. See, what will be the ones complement of this number? I have to scan the number from right to left. Okay, there is no zero, so no problem. First one will be copy pasted, and for rest we will do ones complement. So this will be the twos complement of this number. I hope I have made the point clear. Okay, now please try to run this Turing machine for this binary number also 1011. Okay, and try to run Turing machine for this number also and for this number also. This is your homework, and you will get the crystal clear idea about how exactly twos complement Turing machine is going to be designed. Okay, please pause the video and please note it down everything. I'm jumping to next slide. I hope you have noted down. Now I'm jumping to next slide. Turing machine to add two unary numbers. Okay, how to add two unary number means what? Base is 1. Okay, so base 1 means what? If you want to write 2, you will write double 1. If you want to write 3, you will write triple 1. If you want to write 4, you will write 4 ones, and so on. Okay, and here 1 is a symbol. Please do not consider it as a number. It is a symbol. In place of double 1, you can write double A also. In place of triple 1, you can write triple A also. In case of 4 1, you can write 4A's also, and so on. So unary base means only one symbol is used to represent number. Okay, so I hope I have made the point clear to all of you. So what exactly is unary? It is clear now. So now question is Turing machine to add two unary numbers. Okay, so let me take two unary numbers. Say I am taking 4 plus 3. 4 will be written as 4A's. 3 will be written as 3A's. And in between them we should have a blank so that we can differentiate that between these two numbers. That means we have two different numbers. So first number followed by blank, then followed by second number. This is the scenario. Okay, and here we will have blank, 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 and so on. Okay, so now the question is how to add these two numbers. So basically this should be your input, but and output should be what? 1 2 3 4, and we should have 3 A's here, and here we should have a blank. We should have blanks. So this is the input. 4 plus 3. So answer should be 7. Na? This is the basic meaning of addition. Na? 4 plus 3 is 7. Na? So we should have 7 here. So how this thing can be done? So you may think that, sir, try to make this blank as A and this A as blank. Then you keep on shifting this blank one symbol at a time. Okay, you will get the answer as this. Yeah, you can obviously do it, and in fact this is homework for you. You will do it yourself. I am giving you a very good logic. Okay, or you can say one of the best logic. That will be what? You make this blank as A, keep on moving towards the right. As soon as you find the blank, that means what? The previous symbol will be the A, and you will make this A as blank. That's it. So this is very simple task. Let me give you some idea. You will get proper clarity. Okay, so what I am going to do is, see, Q naught will ignore all the A's. It will keep on moving towards the right in the search of blank. So what we will write? Q naught. Initial state will be Q naught. It will ignore the A. A will remain as A. It will keep on moving towards the right. As soon as Q1 find the blank, blank will be made as A and it will move towards the right. So that means what? This blank is now changed to A, or blank is replaced by A and it will move towards the right. So state will be what? Q1. So now Q1 will ignore all these A's. So A will remain as A and it will move towards the right. As soon as Q1 find the blank, blank will remain as blank and it will move towards the left. Blank will remain as blank and it will move towards the left. That means what? All these A will be ignored. This blank will remain as blank and it will move towards the left. Okay, so state now should be Q2. State will be changed. Why state is changed? Because mindset is changed. Q naught mindset is in the search of blank only and it will ignore all the A's. Q1 mindset will be what? Ignore all the A's, search the blank. Okay, yeah. So so now Q2 will read this A. Now this A will be made as blank. That's it. Okay. So now this A will be made as blank. So how it should be done? Q2 will read this A and make it as blank. And it's your choice. Either move left or right. And you will jump to the halting state, that is H. Okay. So I hope I have made the point clear to all of you. So this is your Turing machine for to add to unary numbers. Please note it down carefully. Let me put everything on one slide so that you all can note it down. Yeah. Now I think it's visible to all of you. Please note it down carefully. Yes. So the next topic is okay or not. So I hope you have noted down. Okay. So next topic is charge Turing thesis, and I will cover that topic in the next lecture itself. Okay. So thank you so much. Bye bye.